Hello everyone, my name is Yaozhong Liang from China. I'm a student of Faculty of Economy, Thammasat University, Thailand. Today, my topic is the impact of China's local economic development level on the development of rural e-commerce, a special effect analysis. This presentation has five parts. Part one is background and introduction. This part includes topic background and research objectives. First is topic background. The consumption level of residents has been dramatically improved with the continued improvement of China's social and economic development. The emergence and popularity of online shopping have made people increasingly dependent on online shopping, which makes China's e-commerce face substantial market opportunities. Moreover, in the context of China's consumption upgrade, consumers' choices are no longer limited to surrounding physical stores, and they tend to choose more online shopping platforms. In this context, huge market demand has prompted the rapid development of China's e-commerce. Compared with Western developed countries, China as a developing country started late in developing rural e-commerce in China. However, due to the enormous consumer growth and the increasing penetration of novel technology, it has developed rapidly, surpassing many countries. At present, in China, the main form of rural e-commerce agglomeration is Taobao villages. Taobao village is a concept proposed by Ari Research Institute in 2009. Taobao village is a large number of online merchants gathered in a village, with Taobao as the main trading platform, forming a novel business class, the phenomenon of scale and synergy. Therefore, this paper mainly uses Taobao as the research object and mainly studies the Taobao to illustrate the development of rural e-commerce in China. Second is research objectives. This paper uses spatial econometrics to study the spatial relationship between China's provincial economic development level and rural e-commerce development level. This paper uses the spatial lab model and the spatial error model, and the dependent variable is the number of Taobao villages. The following three points will be the specific research goals to be achieved in this paper. First, investigate whether the geographical level affects the impact of changes in local economic development levels on the development of rural e-commerce. Second is to analyze the spatial correlation of rural e-commerce development in rural areas. The third one is to determine the impact of spatial dimensions on the development of rural e-commerce and compare spatial econometric models with traditional models. Part two is literature review. The interpretation of space economics by Ashley in 1988 is a series of methods for dealing with the spatial properties caused by space factors. Specifically, this method of measuring economics is based on the reasonable assumptions of spatial effects and makes assumptions, predictions, inspections, and estimates of regional economic models. While in 2000 selected the contiguity metric, the distance metric, and the weight metric based on commuter flow information, and analyzed the role of spatial interaction in the development of rural areas. Huang in 2007, uh, Huang in 2018 found that the Taobao region in Changzhou City has a significant spatial correlation. Moreover, Taobao region shows agglomeration distribution in space and has a characteristic of spreading from southeast to northwest in spatial diffusion. She et al. In 2017 analyzed the spatial distribution characteristics and driving factors of Taobao in China. This paper will refer to their views. Part 3 is research methodology. This part includes data description and econometry approach. First is data description. All of the data was collected from China's Statistical Yearbook, Early Research Institute, China E-commerce Report, and the National Bureau of Statistics of China. All of data are from 31 provinces in China from 2013 to 2018. Second part is econometric approach. When studying influencing factors, if the variables under study do not have spatial autocorrelation, that is, the variables are independent of each other in space, we can use discrete linear regression. If the variables have spatial autocorrelation, we need to use the spatial regression model. The discrete linear regression equation is like the Formula 1. In general, the spatial lag and spatial error model can be written as nested models in their general form as follows, like the Formula 2. According to the assumption of this paper, the relationship between the development level of rural e-commerce and the development and the level of provincial economic development is mainly investigated. So the following model is set like the formulas 3 and 4. Next is the variables of this paper. LMTV is bright variable of this paper, stand for log of the number of Thaba villages. GDP is expenditure variable, stand for China's provincial GDP growth rate. Other variables are the control variables of this paper. POP stand for population of China's provinces. Cluster 1 stand for the value of local autocorrelation based on the Matching. Cluster 2 stand for the value of local autocorrelation based on economy distance matching. IPR stand for internet penetration rate. LMUT stand for log of the number of telephone uses. PSO stand for postal service outlets. RLBFI stand for growth rate of various loan balances of financial institutions. Part 4 is results and discussion. We will talk about this part between different matches. For table 2, we will talk about the model regression analysis based on the Queen-Way matching. In terms of the goodness of fee, the SLM model is better than the OLS and the SEM model and has a better estimation effect on the influencing factors of probability. The spatial lag coefficient is positive and significant at 1%. Probabilities in neighboring provinces increases by 1%, and probabilities in this province will increase by 49.5%. It is consistent with the theory of industrial agglomeration. The GDP growth rate is positively correlated with the number of probabilities. The GDP growth rate coefficient is significant in the SLM model and the SEM model, but not significant in the OLS model. The bias may be caused by OLS model ignoring the influence of geography space. For the table 3, we will talk about the model regression analysis based on the economic distance way matching. In table 3, the fitting degree of the spatial model is greater than that in Table 2, indicating that the spatial model based on the economic distance metric can explain variable more powerfully. However, in terms of the coefficient and significance of overall variables, Table 2 is better than Table 3. In Table 3, the 15-degree R-square of the OLS model is less, less than that in Table 2. In Table 3, the GDP growth rate is positively correlated with the number of top villages. However, it is only significant in the OLS model and SRM model, not in the SEM model. In table 2 and Table 3, the spatial length model is significant under the Queen metric and the economic distance metric. In this case, rho is an endogenous explanatory variable representing the natural logarithm of the neighboring top village. The spatial lat dependent variable has a positive impact on the number of top villages. Part 5 is conclusions. This part has 3 points. First, the distribution of top averages is formed under the combined effects of various influencing factors. The GDP growth rate, total population, internet penetration rate, and the number of postal outlets are the main factors affecting the development of top averages. They, they all play a positive role in promoting the development of Tapa village. Second, from a spatial perspective, the economic development level of various provinces of China has a positive effect on the development of rural e-commerce. The third, China's provincial rural e-commerce development level is affected by neighboring provinces. Finally, we suggest that the Chinese government can formulate relevant policies for the development of rural e-commerce based on the spatial distribution of top villages in various provinces. That's all. Thank you.